we get about 15, 16 frames per second.
All right.
I'm now going to enable Appy to be able to use the OpenCL.
All right.
And we're going to zoom in again. So now all will be done. Exactly the same code. The bytecode gets transcoded on your behalf and turned into the GPU.
All right, do that again.
You want to see that again?
Yeah. Okay. Wow. Cool. Can you show me some code?
Yeah. So I won't show you the Manblock code, but I can give you an example of the sort of transformation you have to go through to use this particular library.
All right.
Here's a trivial example. We have an in buffer and an out buffer, and we're going to actually just sum every element in the in buffer into the result buffer, in and A and B. And in fact, this is the sequential version of the code that all Java developers would know and love. Okay. If we look down a little bit, on the left-hand side we've got the sequential version again, but on the right-hand side we've actually got how we express this in Appy. It's a little longer, and we're using an anonymous inner class. But basically the kernel class, the run method, everything in the run method gets converted to OpenCL and executed on the GPU, and you dispatch the execution over the length of the array.
Okay, so you're saying it still takes a bit of work and a bit of forethought, and one of the goals of Project Sinatra will be, I guess, to make that easier.
Exactly. So here, of course, we have to do some strange tricks and syntactic tricks to get it.
So I have a really short attention span. Do you have another demo?
Sure, let's do that. All right. Right, so the other contractual obligation, we're going to show another, which is the game of life. Anyone who's done CS will have been forced to the exact contractual obligation. So if we start, this is the game of life. Every pixel on the screen is going to follow the rules of the game of life. I started off with a straight line. Again, we get 19 frames per second. Generation.
Let's wrap this up.
All right. So now we're going to switch over to the OpenCL mode. There's a slight pause as we converted the code, but you can now see we get a much more generations per second when we run anything.
Okay, so I have a short attention span. I want to
still
code. So you're saying that the process will help you, right?
Yeah, so the code on the right is still, we're using these anonymous inner classes, and what we're looking at, of course, now with Java 8, is on the left-hand side is the sequential code, and on the right-hand side is where we're heading with Appy. So our plan is to take the lambdas and sort of turn it into the code on the right-hand side.
Okay, excellent. Do you have another one?
Sure, that's one more. feed the beast. Okay.
It would be cool if you could somehow integrate Duke into it.
Well, let's see. I'm not sure whether we can do that. So the next demo that we have to do, obviously, is the n-body physics simulation. This is where you have lots of bodies in free space.
That's not Duke.
This is... There's actually a lot of very small dukes.
2 frames per second?
There's 2 frames. This is multi-threaded mode, 10,000 dukes, all gravitationally attracting each other.
That's even slower than the Oracle standard laptop running World of Warcraft.
Well, so let's do something. Not that I would do that. So let's do something about that. Let's switch to the mode where Appy converts the code in order to be able to do this. Again, the compute is happening now on the GPU instead of happening in multiple threads.
All right, there we go. Wait a second.
There they are.
Those are thousands of little things.
Many little Duke gifts.
Yes. All right. Thanks, Gary. Let's just go wrap up here. Let's talk a little bit about the future.
Sure.
Thanks.